we've learned two properties. We did the multiplication property of exponents, which we can also refer to as the product of powers, where we know if we have the same base, we can add our exponents. Yesterday, we introduced the division property of exponents. If we have the same base, we can subtract our exponents, the numerator's exponent minus the denominator's exponent. So today, we're going to look at something a little different. This is a power to a power. Okay. Can we explain in words what's happening in that expression?
3 squared.
Okay. That's okay.
3 squared maybe to the fourth power.
Okay, so let's explain that a little bit more broken out. What am I going to calculate?
So first we will calculate what's in the parentheses. So 3 squared will be 9.
Okay.
So then you'll take 9, and then the exponent is there, so it'll be 9 to the power 4.
Good. I actually like how Jada broke that out. So she's saying this is actually the same as 9 to the 4th. So what would that be if I broke it out?
9 times 9 times 9 times 9.
But let's say I didn't want to calculate the 3 squared and I just wanted to leave it. Could I break that out? What am I actually raising to the 4th power here?
3 squared.
3 times 3 squared, or 3 times 3. So I'm really, is this the same?
3 squared.
Is that the same?
Yes.
Yeah, 3 squared times itself 4 times. That's what this is saying to me. So 3 squared to the 4th is 3 squared multiplied as a factor 4 times. The product of 4 powers, each with the same base of 3, the exponent of 2. So we rewrote that. Just this section of the board. Now, what property does that look like? It's very similar to what we did on Wednesday, where if we have the same base, what are we able to do? Yeah, we're able to add the exponents. Okay. So I'm just going to go here. It's not fully expanded. We could go further if we needed to. This, how else could I break this out? 3 times 3. And then what's that? So this and this. So while we didn't have it fully expanded, some of you may already see a pattern in this first example. Some of you may want it completely broken out. What do I really have here? What am I really multiplying? 3 to the 8th power. Because as you can see with the full breakout, I'm multiplying 3 by itself 8 times. So now let's talk about what a rule could be. Now, I could break this out at any point in time. I don't need a rule. I already know, based on the first thing we just talked about, that if you're looking at that expression, 3 squared to the 4th power is 3 squared times 3 squared times 3 squared times 3 squared. And I could break out 3 squared is 3 times 3. So really, I'm multiplying 3 by itself 8 times. Again, for those of you that want to have a reference in your binders, this would be your breakout. 3 times 3. And they all equal 3 to the 8th. This is power to a power. Okay, so you're raising a power to another power. What's the relationship? There is a relationship. When we did the multiplication property of exponents, we learned that, well, we kind of discovered it. You didn't just learn it. We went through an example, and you saw that if you had the same base, you could just add the exponents. Yesterday, we had the division property, and you saw, once we broke out the expressions, that if you subtracted the exponents, numerator's exponent minus the denominator's exponent, it gave you the same solution or simplified expression. Now, there's another pattern here. You don't need to rely on a rule. We just can break it out. But what do you feel the pattern would be?
When you're multiplying by an exponent with the same base.
That part really doesn't fit now because in this scenario there's only one base. But continue because I know where you're going with it.
You would end up multiplying the outer exponent to the exponents in the power.
Yeah, you can multiply the exponents. So 3 squared to the 4th is the same as 3 to the 8th because 2 times 4 is 8. If you had another example of like, let's say x to the 3rd raised to the 4th power, that's really the same as x to the 12th because I have x to the 3rd times x to the 3rd times x to the 3rd times x to the 3rd. And if you felt like you wanted to break it out, at this point, you could even just go back to the product property. 3 plus 3 plus 3 plus 3 does give you 12. So those properties are very related. Now, I don't love relying on rule because there is an element of this that can throw you off, which we'll talk about in just a second. But that would be your power to a power. And typically, when you see an example of this or an expression that contains something along these lines, you would see the parentheses. Now, there's other forms of grouping. You have parentheses, you have brackets, but still it really means the same thing. So now using just the rule, because this would be very time consuming to break out. If I wanted to break out 5 to the 8th 6 times, that would be tedious. So in this scenario, it's okay to use a rule. What would 5 to the 8th raised to the 6th power be? 5 to the 48th power. Now, breaking out 5 to the 8th, it's just going to take a long time. If you see this and you can make the connection that what you're doing is just multiplying what's inside there 6 times, you can jump to that rule. 8 times 6 gives you 48. How about the bottom one, 953 to the 7th raised to the 3rd?
953, 21.
To the 21st power, exactly. Good. So how about what do we think?
2 times x to the 6.
So let's talk about this. We're just going to check it. How would we check it? How do we check if our simplified expression was correct?
You can expand your hand.
I can expand it. Let's break it out and just see. So this is going to be 2x squared times itself 3 times. And then we can go a little further. This is the same as 2 times x times x. This is the same as 2 times x times x. And this is the same as 2 times x times x. So let's put it back together now. What do I got?
And then x to the 6.
So what happened? Because this is why I don't like to depend on a rule. Because now you've associated, like, okay, if I see the parentheses, then like the exponent inside and multiply with the exponent outside, we miss something. By just focusing on the rule, you're missing something here.
You have to multiply everything.
Yeah, everything in that parentheses is being raised to the 3rd power here. So breaking it out shows you that you're doing something with the 2. Because the coefficient is also being raised to the 3rd power. So it's 2 times 2 times 2. Again, another reason why I just don't like to rely on a rule in this scenario. But if you did use the rule and you checked it, you'd see that there's something a bit off. And this is the one. This is the one that throws a lot of students off because the majority of students, and actually in pretty much every class I've ever taught this to, when I do a problem like that, they all jump. The first person that volunteers it would have said 2x to the 6 because you still aren't making that connection that you're multiplying everything inside to the 3rd power. But notice what happens when you break it out. And I heard Emmanuel, the second I started, he was like, oh, that was wrong. Because it's when you see it broken out, you can see that you're actually multiplying everything. And you catch that mistake on your own. The most common, I would say this is probably the most common mistake, right? But again, until you've really seen these and experienced them, that's a common mistake. I would expect you to make that mistake. Right? But if you break it out, no matter what property we're dealing with, when you break it out, I feel, you may disagree, that it kind of shows you the path to take here. We're multiplying all of these. I know that x times x times x times x times x times x is x to the 6th, but I'm still left with 2 times 2 times 2. which I can calculate to be 8. So that would be raising a power to a power. There's one other way we can kind of look at this. Okay? This is the technical way we would say it. Power of powers. Okay? You don't need to know the technical. I mean, you do know the technical. You just use examples instead of using variables, which is fine. But now let's look at this example. What do you notice about the bases here?
They're different.
They're different. But what do you notice about the exponents?
They're the same.
They're the same. So could I break this out and have no parentheses? What would it look like if I broke that out? Good. 2 times 2 times 2, which is 2 to the third, times 4 times 4 times 4. I know that middle 4 is awful, but it is a 4. Okay, good. Now, those are the same. Let's see if we can use a property that we've already learned. Is that the same as this? Are they the same? Yeah, what property tells me I can do that? Commutative. I can change the order. I'm just multiplying. Now, is this that the same as that? Yeah, that is the same as that. Now, could I use, I just did, I used the associative property here. Do you remember what that is? The associative property is all about the grouping, meaning if you're multiplying or adding, you can change the grouping. It's still going to give you the same solution. So how many times am I really multiplying 2 times 4 by itself?
3 times.
3 times. So I could simplify that. I heard you, Mortimer. 2 times 4 to the third power. Okay. Now, I feel like this isn't as common. Again, this is my opinion. I don't feel like that is any simpler than that. Like, sure, it's 1 less parentheses, but I just don't feel that it's as simple. But this would be another little property. And in this scenario, if you have a different base, but you have the same exponent, because you're multiplying, you can change the order around and you can regroup them because you can do those 2 properties, commutative and associative, with multiplication. You can change the order and group them together. And this would be, just kidding, this would be the power of powers. I know we did like power to a power, and then power of powers. That could be a little confusing here, but in this scenario, and if you prefer to write the example down, that's fine. I know that sometimes seeing the variables is tough. If you had 2 to the third times 4 to the third, that's the same as 2 times 4 to the third. In the scenario here, you have a different base, but you have the same exponent. You can utilize the commutative and associative properties to regroup them. This would be the power of powers. And again, your bases can't be 0. We're not dealing with zeros in the bases. Again, I don't feel like that one's as common. I mean, you'll see it, but not crazy common. Power to a power, the one we did just before this, you'll see that much more often. Any questions about the power of powers? Now, even for this one, the power of powers, if you broke it out, and you broke out like we just did, 2 times 2 times 2 times 4 times 4 times 4, I don't feel that you would naturally just move the order around and see the grouping. So in this scenario, the breakout may not help you as much as understanding the rule. Like if you know that those numbers have the same exponent, you could regroup. Because in my mind, you're not going to see it with the breakout. When you do the division property of exponents or the multiplication property, I think that the breakout really shows you, especially as you're learning the difference between them, what to do here. Go ahead.
Will we ever see fractions as exponents?
Not until high school. You're not going to deal with them right now. Go ahead.
So what if they're different numbers?
The base or the exponent?
The exponent.
If the exponents are different, then there wouldn't be a way to simplify that. Like if we had, that's a good question. If we had like 2 to the third times 4 to the fifth, there's really no way, because notice if I break that out, now you have an option here. It's not really going to simplify it for you. You could say it's 2 to the 4th raised to the 3rd power and then times 4 squared if you really want. But like that is not, I think you actually just made it more complex. So that wouldn't be, there's really not a property associated in that term. You could like rewrite it. I didn't change the value by doing that, but I don't necessarily know if I simplified it doing that. So this property, where it's a power of a power, is specifically when they have the same exponent. You can regroup it and rewrite it because I mean, I would say this does look a bit simpler than these two terms multiplied by each other. Questions? So we're going to practice a little bit. I've heard some students say like, oh, I really got this. I feel really comfortable as we're going through each of the properties. And I do feel that you're picking it up really, really well. Where there tends to be confusion is when we start to see all of the different properties, like in different orders. Like maybe that one's multiplication, then I'm going to divide it, and then power of a power, power to a power. So that's why for the learning process, breaking it out is totally okay. We're going to have a quiz at the end after we do some practice. If you utilize the rule to get your answer, that's fine. I don't need to see a breakout all of the time. It's really for your benefit. I don't want to rush you to the rule. I also don't want you to only utilize the breakout all the time. We want to try to make that connection because something like x to the 5th times x to the 3rd, you're going to get to a point where you don't need to say x times x times x times x times x, right? You could just say like, oh, the base is the same, it's x to the 8th. Much more time saving and, you know, something that you'll get to. So we're kind of getting to that point. So here's what we're going to do. That's last. Oh my gosh. We're going to do these. Hold on. Really? I hate this one. Sorry, I forgot to erase this. Okay. So if you notice here, we have some examples of what we've been learning today and a little bit of what we learned on Wednesday. Brackets are a way of grouping just like a parentheses. So what you'll start with the first 7 that are circled in red. And then after you do the first 7, I want you to try the bottom 4. They're a bit more advanced, but the process is still the exact same. If you had to look at like number 32, and you had to explain to me what was actually being multiplied, you could really go inside to the outside. What's being multiplied in 32? What is being multiplied here? So it's negative 5xy in parentheses to the 2nd power, brackets to the 5th power.
So you're squaring.
So negative 5xy is being raised to the 2nd power, and then that number is being multiplied by itself 5 times. So you can still break it out and do everything they did before. Start with the ones inside the red square, or rectangle, I should say. Because those are going to be your introductory. Then try to move to those advanced, and you're breaking it out for now the same way. Once you get to a point where you don't feel you need the breakout, try some without it.